We have seen how MDPs can be solved, but before moving on to more advanced algorithms like Q-Learning, it's important to understand a key distinction in reinforcement learning: on-policy versus off-policy learning. This difference determines how an agent learns from experience and is fundamental to many RL methods. As a reminder, a policy defines the agent's behavior. It tells the agent what action to take in a given state. Now, the big question is, can the agent learn only from its current actions or also from past and different actions? Intuition. Think of it like learning to drive, on policy, like learning to drive by practicing yourself and improving from your own current experience. Off policy, like watching recordings of many drivers, including yourself, and learning from all of them. This is at the heart of on policy versus off policy learning. On policy learning. In on policy learning, the agent learns about the same policy it uses to collect data. The behavior policy used to explore and the target policy that is being improved are the same. Each piece of experience is used only once because the policy changes after every update. This figure shows a typical on-policy workflow where experiences are collected during interaction and used immediately for training. They are not stored for reuse in future updates. So it has some pros. It's simple and intuitive, always learning from the current behavior. It naturally includes exploration in learning. Cons. It's less sample efficient. We need fresh data for each update. It can be slower to converge in large or complex environments. Now, off-policy learning. In off-policy learning, the agent learns about a different policy than the one it uses to collect data. The behavior policy collects the data. This can be random or exploratory. The target policy is the one that is being optimized. Past experiences can be reused many times, often with tools like replay buffer. We'll study replay buffer in detail later. This figure shows a typical off-policy workflow where experiences are collected and stored in a replay buffer. This buffer allows the agent to reuse past experiences for training, improving sample efficiency. It has pros. It's more sample efficient because we can reuse older experiences. It can learn optimal behavior while still exploring widely. It also has cons. The cons are it can be trickier to stabilize. We may learn from data that looks very different from its intended policy. This is the summary about on-policy and off-policy learning. In the upcoming lessons, you will see both on-policy and off-policy learning in action. On-policy methods you will learn are policy gradients, proximal policy optimization, PPO. Off-policy methods you will learn Q-learning, deep Q networks, and soft actor critic. You have been now introduced to the idea of on-policy versus off-policy learning. Don't worry if it's not fully clear yet. As we go through each method, you'll build a much deeper understanding. Let's now dive into Q-Learning, a powerful off-policy algorithm that learns the best action to take without needing the model of the environment.
To find the entire detailed lesson with all the instructions, math, and code, visit our website edreate.com. There you can find everything you see here and much more. Plus, you can find the full code on github.com/edreate. So don't wait around and sign up now at edreate.com.